Hi, thank you for spending your time watching our video. So our group will be discussing about quantification of SARS-CoV-2 by plaque assay. So at first, I will be discussing about what is SARS-CoV-2. SARS-CoV-2 is severe acute respiratory syndrome, coronavirus 2, which is before this known as novel coronavirus. This virus can cause respiratory illness known as coronavirus disease, or we can call it COVID-19. COVID-19 has affecting more than 110 countries around the world. So in Malaysia, in 3rd April, so the case has rise up to more than 3,000 cases. So in this kind of pandemic, the government announced a restriction of movement as a way to flatten the curve. Some of the effects of this disease are someone will have the symptoms like fever, dry cough, and shortness of breath. Coronavirus belongs to Coronaviridae family, which consists 4 genera, which are Alpha coronavirus, Beta coronavirus, Gamma coronavirus, and Delta coronavirus. Alpha and Beta coronavirus can infect mammals, while Delta coronavirus and Gamma coronavirus can infect birds and sometimes can infect mammals. So, Beta coronavirus is usually found in SARS-CoV, SARS-CoV-2, and MERS-CoV. This is the structure of coronavirus. It is called corona because the corona represents the crown-like spike on the outer surface of the virus. So I'll be focusing on 2 important structures in this virus, which is the spikes. The spikes is to mediate the movement of coronavirus into the host cell, and this is small envelope glycoprotein membrane, which is alteration of the membrane permeability into the host cell. Basically, this disease spread widely because of the vector, which is bat, that transmit the coronavirus into human, which is the host. That's all from me. So for the next video, my friends will be discussing about what is plaque assay. Thank you.
Hello, my name is Siti Nur Azlin binti Mustafa. So I will explain on what is plaque assay.
Plaque assay can be used to determine the amount of virus that can infect the cells. Each group of infected cell is known as a plaque. It is most accurate method to quantify the infectious virus through the counting of plaque in cell culture. The basis of this technique is to measure the ability of the single virus to form a plaque.
Next, the history of plaque assay.
This technique was first developed to calculate the infectivity of bacteriophage in plant biology. Then, it has been modified by Renato Dalbeco in 1952 to count animal virus. Later, it has been used for determination of titers of many different viruses.
So, what is the advantages of plaque assay?
The first advantage of plaque assay is the ability of crystal violet to identify very small plaque. Secondly, able to quantitate the actual number of virus particles in the sample. Next, do not require expensive apparatus and reagent. Last but not least, very high sensitivity.
Laboratory biosafety guidelines for handling and processing specimens associated with SARS-CoV-2. Handle the specimens using universal precautions, which include the use of gloves, gowns or coats, respiratory protections, and also eye protection. Accurate fit testing is a key component of effective respirator use. Personnel who cannot wear fitted respirators because of facial hair or other fit limitations should wear loose-fitting hooded or helmeted powered air purifying respirators. Procedures with a high likelihood to generate droplets or aerosols. Additional precautions must be followed, such as a surgical mask or face shield or other physical barriers like a splash shield, centrifuge safety cups, and sealed centrifuge rotors to reduce the risk of exposure to laboratory personnel. Site and activity-specific biosafety risk assessment should be performed to determine if additional biosafety precautions are warranted based on situational needs. Decontaminate work surfaces and equipment with appropriate disinfectants. Use EPA-registered hospital disinfectant with label claims to be effective against SARS-CoV-2. Follow manufacturer's recommendation for use such as dilution, contact time, and safe handling. All disposable waste should be autoclaved. Thank you.
Assalamualaikum and good morning. I bid to Dr. Su and to all my fellow friends. I am Nur Athirah binti Amran, and today I am going to present things on the materials and methods that involve in the quantification of the syndrome acute respiratory syndrome coronavirus 2 using the blood assay to investigate the COVID-19 cases. So today I am going to highlight on 3 things in my presentation.
So, in the plaque assay, what we are going to observe as a result actually, we are going to observe the formation of the plaque, which is reversed as the areas of the cell in a monolayer that display the cytopathic effects. So, when we use our naked eye, we can observe the formation of the plaque as a white spot, while if we use the microscope, we can observe the formation of the plaque which appear round and darker than other cells.
The materials in the quantifications of the SARS-CoV-2 using the plaque assay, what we need to prepare to carry out the plaque assay investigation is as I showed in the slides. So what we need to prepare is the Viro E6 cell line for isolation and initial passage of the SARS-CoV-2, the Viro E6 growth medium, the sample to be assayed, which is the SARS-CoV-2, the phosphate buffer cell line PBS, 2 times supplement MEM, 1.6% agarose, crystal violet solution, 6-well tissue culture plate, tighter tube for sample dilution, cell incubator set to 37 degrees and 5% carbon dioxide, 37 degrees water bath, and camera to photograph the 6-well plate. So for the methodology, the first step that involved in the quantifications of the SARS-CoV-2 by the plaque assay is the seedings of the well plate and sample preparation. So in this stage, the Viro E6 cell line sits in the 6-well tissue plate at 1.5 times the power of 6 cells per well in 3 ml of the Viro E6 growth medium per plate. So we can prepare the Viro E6 growth medium using the things that I have listed in the slides. Okay, so the Viro E6 cells in the 6-well tissue plate that we have prepared is then incubate in the cell culture incubator that's set to 37 degrees with 5% carbon dioxide for 2 to 3 days until the desired confluency has been reached. So in this step, what we need to take note is for the best result, we should use the well plate that are 90% to 95% confluent. So for the second step is thaw the sample to be assayed, which is the SARS-CoV-2 in the BSC using the appropriate method to handle this pathogenic microorganism. And then prepare tenfold serial dilution of the sample, which is the SARS-CoV-2 in the phosphate buffer cell line. Mix each dilution thoroughly by pipeting up and down for the few seconds. And what you need to take note in this step is use a new pipette tip between each dilution. So the dilution can be prepared as I showed in this slide, and then add 200 microliter of each dilution to 1 well of the 6-well plate, and then incubate at 37 degrees in 5% carbon dioxide for 1 hour. And the plate that we prepared should be shaped in every 15 minutes.
My friend have explained 4 steps of the plaque assay, and I would like to explain another 5. So for the first step is mix 2 times supplemented MEM with a 1.6% agarose for 1:1 ratio, and then add 3 ml of agarose into each well of 6 plates. After that, incubate the plate into 37 degrees Celsius at 5% of CO2. After 3 days, the plaque can be counted by using the formula.
Now let's look up through each step. So for this step, this is how 2 times supplemented MEM are prepared. So MEM is the minimum essential medium. Here it says that we have to add the 3 ml phenolate. 3 ml phenolate is an optional. So if we add the phenolate, we can easily observe the plaque on the monolayer. We must add agarose with the MEM. Here it says that we have to add 1:1 ratio. 1:1 ratio means if we add 1.5 ml for the agarose, so it means that we have to add 1.5 ml for the MEM supplemented.
3 ml of MEM agarose were put in 6 well plates that contain virus cell in the plate. Then, incubate the plate at 37 degrees Celsius in 5% of carbon dioxide. So it means that we need to use the incubator that we can adjust the carbon dioxide flow. The incubation process needs 3 days. After that, we can calculate the plaque that forms on the monolayer. But before that, we have to follow this step because we need to calculate the plaque on the monolayer. So it means that we have to remove the MEM agarose first. So we can calculate and determine the titer by using this formula, and also we can calculate it manually. The scientists around the world has used the plaque assay to determine the titer, but the plaque assay also has its limitation. The first limitation is the plaque assay only determine some of the subset of animal virus that can lead to the cell lysis, but not all the animal virus can form the plaque on the monolayer. The second limitation is the time taken. The time taken for doing all the steps in the plaque assay method took up for 3 days, although the method is easy way.